Hello, welcome to Dubeke Consult. We like challenges, so we pick a piece of architectural drawing, then work together to produce a detailed drawing that can be easily effected and applied on site. Today, we'll be looking at a key part of every structural design, which is the beam detailing. A comprehensive beam detail should comprise of two important drawings. The first is your beam structural layout, and the second are your beam sections. While your beam structural layout should comprise of vital information like your beam name, the width and the thickness of the beam, and also show you the grids on which they run. Your beam sections should be able to display further information like the reinforcement at the top, the bottom reinforcement, and also your links. It should also show further information like your curtailment length and your cranks where necessary. To see how we were able to model, analyze, and design for the beams we will be detailing in this class, I will leave a link in the description for you to follow. And if this is your first time here, please do not forget to like, subscribe, and follow our channel if you find this video helpful at any point. This is the model we'll be detailing on AutoCAD, and to see how we were able to model, analyze, and design the beams on this very structure, you can go through our channel, and I will also leave a link in the description for you to get to those processes. So to head on to detailing on AutoCAD, we need to first export this drawing from Prota-Structure. And while doing that, let's head on to concrete design. Then we come to beam reinforcement design, and we click on story beams. So here are all the story beams that has been designed, and here are the utilization ratio. So before you export, ensure you've selected the appropriate reinforcement or your desired reinforcement which aligns with your desired utilization ratio of each of the members. So let's close this up, and to export we have to take this to ProtaDetails. So we'll come to concrete designs and we'll click on load ProtaDetails. So we have our ProtaDetails opened up. So you click on auto generate details. We don't need story 0. We'll untick this, then we'll click on draw. Then click on any point on your screen. And here we have the beam structural layout that came with Prota, and over here we have our beam detail. And let's export to AutoCAD. So we'll click on export. And we open this up, continue. So these are the details that came directly from ProtaDetails, and we have here our beam structural layout for the first floor, while we have over here the roof beam structural layout. We have our beam sections over here. I'll copy all the beam sections and copy the floor general arrangement for the levels. I'll right click, come to clipboard, and there's an option for copy, or you can use Ctrl+C on your keyboard. Then I'll come over here and use Ctrl+V to the other drawing. Then I will protect this with a border. So over in this drawing, we have the general arrangement we made prior analysis and design. So this is the drawing that was exported to AutoCAD. It was coined out of the architectural drawing, then exported to Prota-Structure for our analysis and design. We can decide to stick and detail with this, but I would advise you detail with the one that came out of ProtaDetails. Reason being that during the analysis and design phase, you might have made some modification with what you decided earlier during the general arrangement phase. So I would prefer we work with this, and as you can see, this drawing is not as neat as we want them to be. Okay, so we will have to clear this drawing up in order to have our beam structural layout. What I need on this very drawing is the grids. We also need the beam lines. We need the column names and identities. Then we need the beams and their identities as well. So I will select the grid lines and I will ensure all your grids are selected. So I will copy this drawing to somewhere here. Then we'll use the quick select tool. So if I select this and if I look at this layer properties, this is layer, the name of this layer is beam line. All right, and select all of these drawings, right click, come to quick select, come to layer. So quick select helps you to select elements in AutoCAD that has same properties. They can have same color. If you want to select elements that have same color, you can use them. They are under same layer, they have same line types, and all of these other options are listed here for you. So we'll be dealing with layer. So I'll click on layer and come to beam line. So this is beam line and I'll click OK. So you can see all the elements under the beam line has been selected. So I will copy using my CP or CO, copy. Then I'll copy from the intersection between grid line 4 and grid line 1. So I will select from here. Then I will also paste at 4 and grid line A. Okay, so I'll paste this over here. So as you can see, we have a clearer drawing. Let's erase this. So I have a clearer drawing that outlines the positions of my beams. The next thing I'll be copying from here is our columns. So if I click on this, this is under column line. So I will select, use the quick select tool, come to layer, column line, copy this 4 and A. Then I'll come to okay, so now I have my columns and my beams. The next thing I need are the labels. So these are the labels. So if you click on this, this is under beam label. I'll be a little faster. So we've been able to copy out the required elements successfully from this drawing, and we'll be making further modifications to this structural layout. Again, sticking with the beam identities that came from ProtaDetails, which is 1B6, 1B7, 1B8 and the rest, I would prefer we give this single beam a conventional name. So this can be our beam 1, while the next beam will serve as our beam 2. We have a sample of a beam text here. So I will create a copy of this and I'll put this here. Double click to edit, or you type ED on your keyboard. So the first one here will be beam 1. So it is always advisable you work according to your grade. So you move from the topmost grade and move to the second grade. Then you also have to move from your left to right. So if you are identifying these beams, let this be the first beam. Then moving to the next grade, moving from grade A to grade C, this should be your second beam. While going to the right, this will be your third beam. All right. We have to ensure that the beams on each of these grades are identical. So for this first beam here, we have a size of 230 by 450. This is 230 by 450 mm as well, same as this, and every other beam on this grid. So I'll double click to edit once again. Then my beam 1 will be 230 x 450 mm. Then the size of this text is too big, so we'll reduce the size. To reduce, you can right click, come to properties, and you change the text height. So let's edit this to about 200, and 200 is, let's take this to 150. So we'll edit this to 150. Okay, so 150 is good, is better. And we have something here that we need to take out. During our analysis and design, all our column sections are 230 by 230. So I will want only the column names to appear on this drawing, and I will take out all of these other dimensions. Ctrl C, then select everything here. Okay, right click, come to find, and I'll look for this. Then I'll replace everything here with just a space bar. So let me replace all, and now we have just the column names. Okay, there's no need to add the section properties. We need just the column names. So this is better, it has a better look. So I'll bring this down, and this will serve as my beam 1, having 230 by 450 in size. The next will be my beam 2, which is running on grid C. So this will be my beam 2. Okay, then the next, moving from left to right, should serve as my beam 3. Double click to edit or type ED, and this will be my beam 3. Now, to make this job a lot easier, I would prefer, as we are calling out these beams, we are also calling them out on their sections. Okay, so while we call out beam 1, we also call out beam 2. We can as well pick out their corresponding beam 1 and beam 2 from these sections. So you permit me to share my screen, come to view, and to divide my screen, I will come here and click on 2 vertical. So this will serve for my beam structural layout, while this other screen will serve as my sections, all both on the same AutoCAD file. So for the first beam, so for my first beam over here, it spans from 1B33 to 1B6 and ends on grade 8 at 1B10. So I can search for either of these beams. I'll come to this other screen, select everything here, right click, come to find, and I'll look for 1B9. Okay, so let me find this, and as we have it, this is our beam 1. This is our supposed beam 1, which spans from 1B33 up to 1B10. 10. Okay, so this is our 1B10. So select everything including the section, select, and let's move this out of this place to somewhere here. Come back to this screen, can copy this, copy selection, come to this screen and paste. But the text style of these other annotations is smaller, so let's increase this to come to properties and increase this to, let's try 250. Okay, so I think 250 is better. 250 is actually better. So this is our beam 1 identified, and let's make modification to this error. So these are the few errors that occurs from Prota-Structure, and you have to make these modifications yourself. So this runs from, as you can see over here, 1 asterisk. So let's change this to 1. Okay, then let's take a look at the sections. So there are a few other modifications we'll be making on this beam section. So if you look at this beam over here, we have our reinforcements called out with alphabets. So we have A, B, and C, and AA is our bottom bar. So we have AA here, which is our bottom reinforcement. Our BB is our top reinforcement, while the C is called out here as our links. So the A is Y16, the B is Y16 as well, while our C is Y10. For me, I prefer calling these reinforcements out directly, so we can have something that looks like this. So if you are having these issues, it's not actually an issue, it's just a preferred way of detailing. So if you have this coming from your Prota-Structure, but you prefer detailing your beams in this manner, what you need to do is, in this manner where you have the reinforcement called out directly with their sizes and the numbers, so all you need to do is go back to your Prota and edit some of your settings. So you come to concrete design, come to beam reinforcement design, story beams, and click on settings and parameters. When you click on settings and parameters, come to your detailing. Okay, and on your detailing, come down to your steel bar and links. So we'll click here, and there's an option, because that method of detailing where we have A and B, where they are annotated by alphabet, is actually an I/E method of annotation. So you untick this. When you untick this, you will observe your reinforcement has been called out directly. Okay, so ensure this is unticked and you click OK. Now, one more concept of beam detailing I will want to remind us is, if we have a continuous beam that looks just like this, ideally and conventionally, under normal loading circumstances, we have our maximum moment at the bottom when we are at the span zone, while we should have our maximum moment at the top when we are at the support zone. So in turn, we should be having higher reinforcement at the bottom in this section, while higher reinforcement at the top when we get to this section. So this is an ideal scenario. Then for this part, it all depends on your fixed end condition. Okay, so with this idea, if we take an example of any beam, we should have a difference in reinforcement when we move from the span onto the support. An example is this beam. We have 2y16 here at the span, while we have 3y16 at the support zone. But with our current settings, Prota-Structure and ProtaDetails has been able to give us just one section for this beam. So the section was cut at this support zone, but we need to provide a section that also captures this span, okay, that also captures the reinforcement that will be at the support zone rather. And in this case, so if you are not using a conventional reinforcement, you will have cases like that. So there is need for us to cut a section through this place, and we can cut a section through here as well to get the required reinforcement, because if you have to leave this to chances, if you have to leave this to chance and expect the artisans to, although they have to do a thorough check while implementing, but if we have further sections with these beams, that shows that when we get to the support zone, we are no longer sticking with 2y16. We have to implement 3y16 in order to counter the moment at this zone, okay? So we have to cut further sections on each of these beams. So what I will do is go back to Prota and head on to story beams, settings and parameters. We'll click on detailing and we'll click on sections, okay? So as you observe our settings for the sections here, our sections are cut at different beams, but we'll cut this at all beams, so we have a section through all the beams. Then for this part, we'll cut a section at the support and the span, not just the support zone only. So we'll click on support and span sections. So now we have a section through each of these support and the spans. So we'll click OK. Yes, we'll save and we'll close this up. Then we'll export back to ProtaDetails. If you find this video helpful at any point, do not forget to like and subscribe to our channel. Also turn on the notification bell so you get notified anytime we post new videos on our channel. So we'll minimize this, click on auto generate. We don't need story 0. We'll draw and we'll click on any point on your screen. And let's navigate to our beam sections. So as you can see, we have a section cut through all of the span and the support zone. So let's quickly take this to AutoCAD. We'll export and we'll replace and override and close this other drawing over here. Let's close this. Then we'll come back to ProtaDetails. We export again. Okay, and let's override. Double click to open. Okay, and now we have a lot of sections. So the first modification we've made is calling out this reinforcement directly, but now we have so many sections, but we'll not be making use of all of these sections. I will show you the easier way we can work with this. So let's copy out our beam, our layout, and every other reinforcement remains intact. So let's copy this, come back to here, and we can delete this and this. So we'll paste, Ctrl V. Okay, then now we can search for And now we can search for our beam 1. So permit me to divide this screen again. We'll divide this. Our beam 1 is still 1B9, 1B8 and the rest. So we'll select all of this, right click, come to find 1B9. all right, so we'll select this and all the corresponding sections. And we'll move this over to this part. So let's make a copy of the identity. We'll copy and we'll take this to 250. all right, so this becomes our beam 1. And let's cut our section through the support and the span zones, because we will not be making use of the section lines that came with Prota. We'll be making use of our own section lines. So I have a sample here. I'll come here and copy this. You can actually get this template online, and there are numerous templates you can get. You can get the JGD templates. You can, another wonderful template we have out there is the Stonebridge template. So it helps you, it just makes your work neater. Although you can do this with the drawings that came directly from Prota, but when you put this in a template, it helps you in making some modifications that helps your drawings to be neater. So the first section is we'll cut through our cantilever, and the next is we'll cut at, so our cantilever will cover the support zone for this section. Then the next is we'll cut a section at this span, and we cut another section at the support. Then we cut another one at the span. Then the last is here. Okay, so we should have about 5 to 6 sections for these beams. Let's make this a single layout. So for the first, or let's take it back, for the first beam we have for the first section here, which is between 121 and 122. So if you observe, we have both 2y16 at the top and 2y16 at the top here, and 2y16 at the bottom. So it means what we have here is conventional to what we have over here. That's for the support zone. So we don't need to take each of these sections along. So between these two, I will have to delete one. I'll erase this, and this becomes my section 1 to 1. So this is section 1 to 1. Okay, now at the span zone we have a section here, still 2y16 here, which is section 123. So we'll be keeping this for the span section. Okay, so we'll take this to section 2 to 2. Okay, then coming to the support zone, we have 3y16 at the top and 2y16 at the bottom as well. So that is between section 124 and 125. all right, so between section 124 and 125, we'll pick just one of these. So I'll erase this, and I will stay with just this other one over here. So let me edit this to section 3. 3/3, and this becomes my section 3/3. Moving on to this should be our section 4/4 at the span zone. So let's come here and we have section 126. So this is section 126. We've moved, you can see that at this 126, and the reinforcement, the 3x16 at this top zone, will extend 1.15 meter from the center line of this column to this point. So you don't have to run it all through, you don't have to run the 3x16 all through this section if you are doing a very cost-effective design. What some persons do is they look for the worst case scenario, something like this. They look for the worst case scenario, this that has the 3x16 at the top and 2x16 at the bottom, and they use this worst case scenario to be the conventional reinforcement for this single beam. Okay, they cut just one section through this beam and use that conventional reinforcement all through the span. So that is a good design philosophy, but it is not advisable when you are also dealing with cost and when it does not affect life and properties. So imagine you have to run the reinforcement all through the length of this beam when you can only run them at about 1.35 meters when you get to this support zone, 1.35 meters to this section, and also 1.2 meters to this section. So we head on to the next, which is section 4 at the support, and we have section 126 to represent that. So this becomes 4 and 4, while this changes to section 4 and section 4. Okay, our next is at the support zone. So on this support zone we have 128, section 128 and 127 to cater for that, and we'll pick only one. Okay, so this is section 127 and section 128. We'll pick this. This is as a result of the lapping. Okay, this is just as a result of the lapping of this reinforcement due to its total length. So not because we have to combine two levels of reinforcement. So I will take this out for confusion because of so it doesn't lead us to confusion, and edit this to be my section 5 and section 5. And one more modification we can make is, since there is no change in the reinforcement, we can stick with this 2y16 till the point where we have a change in, we can cut a section where we observe that there are changes in the reinforcement. Okay, so we'll stick with this. We stop at section 6, so 132 becomes section 7. Let's erase every of these section lines so our drawings become neater. Okay, so if I select this, I have section line. Let me use the quick select. Come to quick select and select our section line. Okay, so all our section lines has been selected, and we erase. The next is section label. So we'll select this beam, come to quick select, layer, and section label. Quick select, section label. Okay, so now our drawings becomes neater. So we have our sections all called out, and like I said earlier, some detailers will prefer, let's make a copy of this. We prefer having just one section on this beam, and they use this worst case scenario, which is 3y16 at the top and 2y16 at the bottom. So the beam can have just one section, but this leads to is not financially advisable. So the next thing is, we'll continue for the next beam, which is our beam 2. And as we have over here, our beam 2 is 1B27, from 1B34 to 27 and to 1B28. Okay, let's delete this duplicate, then we'll search for 1B28. So we'll come here, select, come to quick select, layer, come to find, and 1B28. So we'll find this, and here we have it. So we can copy this here to be our beam 2, and let's confirm the sizes. Let me take this to a single page, and I think it's better we rename. Let's rename these beams before we start with the sections. So this becomes beam 2, beam 3. Moving to the next grid, we have this to be our beam 4, ED for edit, and we can move our column label here. Okay, this becomes beam 4. We'll copy to here, and this part. Okay, so this is 4 and this becomes 5. So our beam 3 is 230 by 450. This is 230 by 450 as well. So now we are done with our beams on the horizontal axis, and let's move on to the vertical axis. So I will copy this. Let me make this a single screen. I'll copy this beam, CO, and I'll rotate this. So this will be a single beam. This becomes beam 8, followed by this. Beam 10. So over here at beam 10, we have 230 by 600 beam. All right, so we'll come down here and we'll edit this to 600. Okay, beam 11, 230 by 600. So now we have our beam called out to our own specification. What we can do is take out these beam labels. So our beam 8 is 1B2. So let's divide the screen as usual. Let's put this here and put this other one here. Come to find and 1B2. This is 1B24. So we'll find next 2526. Now we are done with identifying the relevant beam sections we need to cut. The next phase is clearing these drawings up, and we put them on a sheet. So for this other drawing, which is the beam structural layout, we'll be deleting our beam labels that came from Prota. So I will select this, and is under beam label, that's a layer. We'll come to quick select, we'll look for layer, beam label, and we can erase. So now we have just beam 1, beam 2, beam 3, 4, 5, 6, and the rest. So we'll take out this grid line that is not required. Okay, so this is our beam layout, and the next phase is clearing these sections up. So if we select this section number, we have section label. So we'll select all of these drawings, come to quick select, so now we have a clearer drawing. The next phase is putting this on the sheet. We have our title block over here from our template. You can get our template online. A link will be in the description. It makes your work easier once. And let's scale this down to 65%. So we'll type 0.65. What you can do is, if you double click, you can edit and you can insert your company details here, your detailer, who designed, approved, checked, and the rest. Okay, so let me go back to my drawing, and I will scale this to, let me add 15% or 20. Let's scale to 1.20. Okay, I think this is better. So yeah, this is better. I can as well scale by 0.5%. So 10%. Okay, this is a lot better. So now I have my structural layout. This becomes my beam structure. All right, and I will include my dimensions. And let me match properties from here. You can get all of this from the template. Then I'll continue the dimensions to this part. Okay, dimension here, and we'll match So now we are done with our beam structural layout, and we have to put our beams sections in another sheet. So we'll copy this sheet and we'll come down to here. Then we'll move our beam 1. Let's move our beam 1. As you can see, the length of our beam 1 is bigger than the size of our sheet, and it is better you cut this beam. Let me put this here. So it is better you divide these drawings into two, the beam section into two, other than increasing or scaling up the size of your paper or your sheet. Why is that important? If you have to scale this sheet, the size of the paper becomes bigger and bigger, and the size of the drawing that will be placed in that paper will be very, very small as compared to the size of that drawing. So if you're having cases like this, what I'll advise you do is you divide this same drawing into two different lines. So I will show an example. I will copy this very section into two. Let me copy this into two, or let me erase this. Then I come to my express tool and let me bring out my break line symbol to indicate. Okay, so this is my break line symbol. So we have our break line symbol now, and let me match the properties with this. All right, and we can drag this up and drag this up. Okay, so let's see if this can fit in. So yes, this can fit in comfortably. Okay, so we'll move this further a little bit and we'll make a copy of this downward. So for the first one, we'll be cutting this part out, while for the second one we'll be cutting this part out. So for this first one, we'll select all of this and we'll trim every other thing. Okay, so we'll trim every other thing. Then for the second part, we'll select this as our point of reference and we can trim every other thing out. So this will become our beam 1 continued, and we'll move this to this part. Okay, so this becomes the first of this beam 1 and this becomes the second of our beam 1. So now we can take out this IB1 and IB9 and the rest. So this is under layer beam label D. Okay, so we'll select this, come to quick select, and we'll look for beam label D. Okay, and now we can erase. Then the next is lining up our sections. So arrange this to be in an orderly manner. So let's move this. Okay, and I can think we can still cope with this two. Okay, just one. So this will come here, and the rest will come over here. All right, so here are the details for our beam 1, and we'll move on to the next, which is the beam 2. If you've adhered to the previously said processes, you will arrive at something that looks just like this. And here is our beam structural layout. We have below here our beam sections, and we'll go ahead to see what this looks like when it's plotted as a PDF. So let's come back here, press Ctrl P on your keyboard, and we'll be plotting this title block as our boundary. We'll plot the next page. So here is a plotted PDF of what our drawing looks like. So here is the beam structural layout. These are the sections of the beams. So if you found this video helpful at any point, do not forget to like, subscribe to our channel, and also turn on the notification bell so you get notified anytime we post new videos on the channel.